Alright, so let's continue on with the review here. So simplify each number using an imaginary number I. So what's going on here is we have the square root of a negative numbers. We used to not be able to do that. But now think of this as just being a negative 1 out in front. And then simplify the rest of it like always. So what we can do here is I know I can square root of 9 to get a 3. I can square root of negative 1 to become an I. So we've got 3i, and then this square root of 3 didn't make it out. Now the reason we don't have a plus or minus in front of these is because we're not solving an equation with them. We're just simplifying one radical, just there, not within an equation. Alright, so this one, 81 is a perfect square for 9. Square root of negative 1 is an I. Got 9i. And then sometimes square root of 7 can't be simplified any, but we can take out that negative and we have I, square root of 7. Alright, this part here we did not do this year. So cross that out there. That is using the imaginary axis to graph imaginary solutions, and then finding the distance from the origin, which does have some use in electromagnetism in physics class and magnetic fields, but we won't be getting into that. Alright, so simplifying these expressions. It is as simple as combining like terms, but we also talked about being able to type in I on the calculator, and that is second decimal point. Above that, you'll have the little I. So some of these, honestly, is going to be faster than typing in on the calculator. For example, this one, combining my like terms. 7, and then minus 2i. Don't type that in. You're just going to waste time. Probably the same one for this one here. You could distribute, and then combine your like terms. You get negative 4 plus 7i. Ones that get a little more complicated are when you have division here. And if you want to see all the steps about multiplying by the conjugate, you can check out the answer key on that. If you're going to go with the calculator method, because that's really all I need us to have us do at this level, make sure you put your numerator in a parenthesis before you do your division on your calculator. So really, for you guys, it would look, I guess, more like this if you're typing it out, not using a fancier version on the calculator. You push that division button in 8i, and then that will simplify it for you. And you can hit math enter on the end of that and get 1/4 plus 3 over 8i. If you want to see the steps of doing it by hand, by the converse, which would be multiplying both the numerator and denominator by negative 8i, you can check that out on the answer key. I'm trying to keep the video brief, though. On this one, multiplying, still not that big of a deal. Probably won't need to type that in. We get 20i minus 12i squared. I squared becomes a negative 1, turning this positive, so we have a positive 12 plus 20i. Just make sure that you put your constants out in front. So this one here, definitely a good example of typing it in on the calculator. If you wanted to do it by hand, you need to multiply both the numerator and denominator by the conjugate here. Alright, you can see the steps for that on the answer key. But if you type this in on the calculator, make sure you parentheses your numerators and denominators. In this case, hit math enter at the end. You'll get your 22 over 13 minus 6i over 13. Alright, and you don't have to do the long drawn out way you'll see on the answer key. You can. You'll need that in pre-calculus. But for now, right now, if we're comfortable with typing in the I button, we're in good shape. Alright, so factoring these here. You might recognize this as if I gave you x squared minus 36, you could factor that to x plus 6 x minus 6, right? Because then when you FOIL this out, you get your x squared, you get a minus 6x, you get a plus 6x, and you get a minus 36. These would cancel out, taking you back to your answer. The problem is on this one, it's a plus 36. So when you see this scenario, you're going to have to recognize, hey, this is essentially the same thing as what we just did, factoring this one, except how can I generate an extra negative sign here at the end to turn that positive? Well, we do have a tool to help us generate an extra negative sign, and that's going to be bringing in I. All right, the impact it would have on this work shown up here is it would add on an I here and an I here, but those would still cancel out. But then it would give us an I squared, which turns -1, thus turning that positive. All right, so there is our answer. Okay, so with that, there can be some GCFs in there. So x squared plus 4 to get x plus 2i and x minus 2i. Right? And then this one, there's a GCF on 26. I'll leave that one for you guys. This one here might freak people out, but it's just 1/3 and then x minus 1/3 I. All right, because the 1, if you think about multiplying these, 1 and 1 give me 1, and 3 and 3 give me 9. The i's help generate that extra positive, and our middle terms will still cancel out. All right, this page here, I'll do one here at the top and then cut it off so that you guys can still have some of this to look at on your own utilizing the answer key. And a lot of this stuff is very fresh. We did this right at the end of the chapter, except for 28 and 29. So I'll have us take a look at these. And both of these are going to have imaginary solutions. Neither one of these are going to be good candidates for any other method except the quadratic formula. I can't complete the square very easily because of this 2 and this -3. All right, so let's do one here. All right, so we have -b. Oh, let me change here. -b plus or minus the square root of b squared minus 4ac all over 2a. Our b here is a 2. Our a is also a 2. And then our c is a 5. So I got -2 plus or minus. All this under the square root would be 2 squared to get a 4. 4 times 2 is 8. 8 times 5 is 40. So we have a 4 minus 40. It's going to give us a -36 underneath that square root all over 4. We know the square root of -36. It's 6 with an I. All right, then we can divide both of these simultaneously by 2's. And we will get here that we have a negative, -1 plus or minus 3i all over 2. And that's as far as I can take that one there. All right, let's take a look at our second one here. Similar scenario, got some negatives in this one though, but we have -b plus or minus square root b squared minus 4ac all over 2a here. All right, our b is a 2, a is a -3, and then our c is a -10. So simplifying, we got a -2 plus or minus square root of stuff underneath the square root. We've got a 2 squared for 4. I've got 3 negatives, so I've got negative, negative, negative. 2 of them will turn positive. 1 more will leave me negative. So on this, 4 times 3 is 12. 12 times 10 is 120. So 4 minus 120 is going to give us a -116 in there. All over -6. All right. So looking at our negative 116, I know there's going to be an I in there. It's also going to simplify down to, so let's go ahead and think of this as negative 1, 4, and 29. And it might take you a little bit of time to find a perfect square in there, but just start dividing. If you divide it by the very first one, which is 2 squared for 4, you can find that that one does indeed work. So here's the stuff we can square root. It can bring out an I, it can bring out a 2. So you have negative 2 plus or minus 2i square root of 29 all over negative 6. All right, can do some simultaneous simplifying, dividing everybody by 2 there to get a negative 1 plus or minus I, because the 2 got divided, 29 all over negative 3. All right, so those answers look strange because they've got square roots and i's in it, but that is indeed those answers. All right, so this bottom part, I'm going to leave this up to you. We just looked at this. It's very fresh. Answer key is posted. You can take a look in on that to help you out, and also ask me further questions on it.